In this video, we're going to continue to look at section 7.1 on preference voting. We're going to start by where we left off in the last video. We were talking about pairwise comparisons. And what I want to talk with you about now is how do we know how many pairwise comparisons there are going to be? Well, this is how I figured out. I usually figure it out by drawing a polygon. Here we see a triangle, so if there are three candidates, candidate A, B, and C, there are only going to be three comparisons, A to C, A to B, and B to C. If there are four candidates, A, B, C, and D, you have all of them. You have all of the comparisons that are the outer segments of the square, but you also have the diagonal comparisons. So A will get compared to D, C, and B. B will be compared to A, D, and C, and so on. So that means there are six for outside segments and then the two cross segments. If you have five candidates, there are the five outer plus 1, 2, 3, 4, 5 more. So 10 total comparisons. So the formula becomes the same formula that you get when you're trying to determine how many sides and cross segments there are in a polygon. And that formula is n times n minus 1 divided by 2. So if we had five candidates, as we did in this shape, you take 5 would be n, times n minus 1 would be 4, and divide that by 2. So 20 divided by 2 is 10, and that's how many comparisons we said we would have here. We probably would not be looking at a 5-candidate comparison, but if we did, that's how we'd find out how many comparisons there would be. Now, when you have a preference schedule, you'll run into something called Arrow's impossibility theorem, which says that there is no perfect way to count all the votes. What Arrow's impossibility theorem states actually is that no voting system can satisfy all four fairness criteria in all cases. So it's kind of funny here because Alaska has gone to the method of plurality with elimination, but you're always going to have a candidate that is upset. We have seen that in our elections here. So here are the four fairness criteria that should cover an election. So if a candidate receives a majority of the first place votes in an election, then that candidate should be the winner. That's the majority criterion. The Condorcet criterion says that if there is a candidate that in head-to-head comparisons is preferred over by the voters over every other candidate, then that candidate should be the winner. This is known as the Condorcet candidate. In the monotonicity criterion, it says if candidate X is the winner of an election, and in a re-election, the only changes to the ballots are changes that favor X, then X should remain the winner of the election. And the independence of irrelevant alternatives criterion says that if a candidate X is the winner of an election and one or more of the other candidates is removed from the ballots and the ballots are recounted, then X should be still the winner. So let's look at the Condorcet criterion violated. That's criterion 2. So let's figure out this winning by plurality and pairwise comparison. Suppose you have a vacation club trying to figure out where they want to spend next year's vacation. The choices are Hawaii, Anaheim, or Orlando. And the preference schedule for this selection is below. So we can see the number of voters were 1 in the first, 3 people chose this ordering, 3 chose that ordering, and 3 chose that ordering. If we let's have you guys determine who wins by plurality. Now remember, plurality is who just has the most first place votes. Not a majority, but just the most. So who won this election by plurality? Looking at the preference schedule, we can see that Anaheim had 4, 1 plus 3 first place votes. Orlando had 3 and Hawaii had only 3. So it looks like Anaheim wins by plurality, most first place. Now, if you add all these together, you get 10. So there were 10 votes cast, 3 plus 3 plus 3 plus 1. Anaheim only had 4, so they don't have a majority, but they had plurality. Let's look at pairwise comparison. In pairwise comparison, we see we have 3 candidates, so we'll have 3 comparisons between the candidates. If we look at A versus O, you'll be comparing all of these with just the O and the A. So in my first column, A is first place, so they get that point. In my second column, A is in first place, so they get all 3 of those points. In my third column, O is in first place and gets those 3 points. And in my fourth column, A is ahead of O, so A gets those points. So it looks like here A has 7 and O has 3. So in my point tally, A will get that point because they won that election. Now we look at A versus H. A versus H, A will get the 1 point in column 1. In column 2, A is ahead of H, so A will get those 3 points. In column 3, H is ahead of A, so H will get those. And in column 4, H is also ahead and will get those 3 points at the top of the column. So it's 6-4, and it looks like H is giving A run for its money. Now, if we look at O versus H, in my first column, O is ahead of H, so O will get that 1 point. Second column, H is ahead of O, so they will get the 3 points. Third column, O is ahead, and we'll get the 3 points. Fourth column, H is ahead of O, and we'll get those 3 points. So here, 6-4, O is winning 0, but H wins this one. So H won here and here. H has 2 points, so H is the winner by pairwise comparison. Okay, so let's look at why the Condorcet criterion is violated. If we go back up here, it says the Condorcet criterion is the candidate in head-to-head voting should win. And if they don't, then the Condorcet criterion is violated. So here, if this vacation club decided to go with Anaheim, they would be violating the Condorcet criterion because in head-to-head comparisons, Hawaii is the winner in 4 cities. Anyway, so that's how that worked. And that was us practicing doing plurality and pairwise comparisons. In our next example, we're looking at the monotonicity criterion violated. So here we have a voting system for a mayor. The resulting preference schedule for this election is shown below. Now we're going to start with plurality with elimination here, and that is the same voting system they used in Alaska, where they called preference voting. Anyway, in plurality with elimination, we eliminate the candidate with the fewest first place votes. Looks like Adams has 37. Brown has these two together. So Brown has 22 plus 12. So it looks like Brown has 34. And Carter has 29. So Carter has the fewest first place votes. And as we go down to our next page here, we can see that we eliminated Carter. Carter gets eliminated wherever he shows up. That means in our new preference schedule, it's kind of like Adams is second here and here, and Adams is first in this column. So let's total who wins. In this voting method, we look at who has the most first place votes now. So now Adams would have the 37 votes from the first column and the 29 votes from the last column, which makes 66. Brown would have these 22 votes. It's still just 22 plus 12, which makes him quite a few less. Now, if we go on here, it says that suppose that results were announced, but then the election officials accidentally destroyed the ballots before they could be certified, so the election had to be held again. Wanting to jump on the bandwagon, 10 of the voters who had previously voted for Brown now choose to vote Adams and then Brown and Carter. So they had voted before Brown, Adams, Carter. That's this column here. They changed their vote to Adams, Brown, Carter, and no other changes were made. So if we look at that voting table now, you can see that 10 of the people from this column went over to this column and went Adams, Brown. So this is the new preference schedule, and Brown shouldn't win because he only has 24 first place votes. Adams now has 47 first place votes, and Carter has 29. But in when we do plurality with elimination, we eliminate the person with the fewest first place votes. So now we'd eliminate Brown, and if we check it, Adams would have this 47 and have this 2. So 47 plus 2. But Carter doesn't get this column, but gets this column with 22 and gets this column with 29. So that makes 49. This is 51. So now Carter wins. But that is so strange because the only changes in the ballot shouldn't have affected Adams. So what this is known as is a violation of the monotonicity criterion. Right. So let's look at the majority criterion violated. Here we have, suppose a group is planning to have a conference in one of 4 Arizona cities, Flagstaff, Phoenix, Tucson, or Yuma. The votes were for where to hold the conference were summarized in the preference schedule below. So now we're going to use the board account method on this versus majority. Well, let's look at majority. Who would win by majority? Let's see if we add all these together. 51 and 25 is 76. This makes 86. And 14 means 100 people voted. So you can see here, Flagstaff wins by majority. Word count is the point system. So since there are 4 choices, the 4th place choice will get 1 point each. The next last to the last will get 2 points, and etc. This will get 3 points. And the first place votes will get 4 points. So the way we do this is Flagstaff was in first place 51 times. So 4 times 51 is 204. So we go and we put all the points in here, and then we add up. I'm going to pause the video and ask you guys to do the board count here and see what you get. So what we've done is in each of these places on the table, we put how much points that was worth. So for example, Phoenix here was in 2nd place, which was worth 3 points. So since there were 10 votes in this column, Phoenix will get 3 times 10, or 30 votes in that box. And that's how we filled in all these boxes. Then we continue and we add up all the points for each city to see what they get. Let's see what you get. So in our calculations here, when we added up all the points for each city, we find that Flagstaff gets 253, Phoenix gets 325, Tucson 228, and Yuma 194. So that makes Phoenix the winner. But thus we violated the majority criterion because the majority was won by Flagstaff in just by having the most first place votes. All right, let's look at our next example, which is the irrelevance, no, the independence of irrelevant alternatives criterion. Even if I can't say it, it's good practice for us to do it. So here, the committee is trying to award a scholarship to one of 4 students, Anna, Brian, Carlos, or Dimitri, and the votes are shown below. You can see how many people voted. If you add across the top, you get 10 and 10, you get 20 people voted. Okay, so now there were 4 candidates, and there are going to be 6 pairwise comparisons. Because remember, if we did that formula for the number of pairwise comparisons, it's n times n minus 1 divided by 2. There are 4 candidates, so this would be 4 times 3 divided by 2, or 12 divided by 2, or 6 comparisons, which is what we have here. Now, if we go, let's start with A versus B. We'll do this one together, then I want you to do the rest. We look at A versus B. In my first column, A is ahead of B, so A will get those 5 points. This is for A. In my second column, A is ahead, and A will get those 5 points. In my third column, B is ahead, and in my fourth column, B is ahead. So B has 6 points plus 4 points, because those are the numbers at the top of the columns. So since they both got 10, they tied. So A and B tied, they both get a half a point. I'd like you to try the rest of them, and let's see what you get. So in this matchup, we compared who was ahead. So for example, when I look at this comparison with B versus D, in my first column, D gets those 5 points, that's here. In my second column, B is ahead of D, so he gets those 5 points. In this column, B is ahead of D, so he gets those 6 points. And in this column, B is ahead of D, so he gets those 4 points. And when we totaled it up, this was 15 compared to the 5 points that D got, so B won. Now, every time that they won, they got a little slash mark over here. And the person who won most was C, because A and B had that tie in the beginning. So Carlos wins. Now, suppose that Dimitri didn't really qualify for the scholarship at all. And it shouldn't make any difference because he only had 1 vote. So the committee decides to recount the vote, though, with a new preference schedule without Dimitri. That's below, so let's look at that. So if you eliminate Dimitri, like if you eliminate Dimitri here, 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 and here, then this column, A, C, B, and that column get combined together, because so that'll be the 10 that we see down here. And the other 2 columns, everybody just slubs it up. Now, since there are only 3 people to do the pairwise comparisons, we do it again. So let's do it again, and let's see what you come up with. When recalculating using pairwise comparisons, we get another tie between A and B, so they each get a half a point. But then A wins and C wins in the third comparison, leaving with A with 1.5 points, where C only got 1. So now Anna wins. So this violates the independence of irrelevant criterion. I always mess up saying this one, the independence of a relevant alternative criterion, because Carlos should have still won if they eliminated Dimitri. All right, in summary, these are the ways that you might have possible violations. Another summary about voting is insincere voting. And that's when a voter will not vote for whom they most prefer because they're afraid that person can't win. So they vote for a person who they think has the best chance of winning over the person they really want to win. And then occasionally you will see approval voting, where you just vote for the candidate that you approve of or disapprove of, and you do not make a preference schedule. We're not going to have too much to do with that, but that is another type of voting. And that concludes Chapter 7, Section 1. If you have questions, please come to my office hours, or or write me an email, and I will be happy to answer.